Assalamu alaikum. My name is Hamza Masood and my registration number is 16T49. I am a student of UT Texla Telecom Department. Let's start our lecture. In lecture number 8, we will study how we apply the discrete Fourier transform on discrete signal. So this is the main formula for DFT, that x of k is equal to summation n is equal to 0 to n minus 1 and x of n e power minus j2 pi nk divided by capital N. So what are these variables k, capital N and small n? Where k is the number of frequency component that are involved in our signal and n is equal to number of sample signal in time domain, and capital N we can choose any capital value of n, but it must be greater than or equal to the number of samples, that is n. So we are taking example. We have a sequence x of n is equal to 1 to 1 0, and now we apply this formula. We are taking the value of constant and applying the summation on a whole. Let's take k is equal to 0 for 0 index. This is our 0 index. Sorry, I have not mentioned here. So k of 0, this means that we are taking k is equal to 0. So it is equal to summation n is equal to 0 to capital N minus 1 x of n e power minus j 2 pi n. Value of k is 0, so we are putting 0 here, and capital N. So we are taking the capital N as the number of sample. At least it must be equal to the number of samples. So we have 1, 2, 3 and 4 sample. We are taking capital N is equal to 4. So by putting this 4 in this equation, we will get again summation n is equal to 0 to n minus 1 means 3 x of n e power minus j 2 pi n into 0 divided by 4. Now taking k is equal to 1, we will get x of 1 is equal to summation n is equal to 0 to n minus 1 x of n into e minus j 2 pi n, where k is equal to 1, so we are putting here 1 divided by 4, and x of 2, when k is equal to 2, we get summation n is equal to 0 to 3 x of n into e power minus j 2 pi n into 2 divided by 4. Now our last value when k is equal to 3. We have summation n is equal to 0 to 3 x of n e power minus j 2 pi n of 3 divided by 4. So number of frequency component we have 3. So we are now expand this summation and calculate our result. So x of 0 is equal to x of 0, first n is equal to 0 and e power minus j 2 pi n is 0 and also k is 0 divided by 4 plus x of 1 e power minus j 2 pi 1 into 0 divided by 4 plus x of 2 e power minus j 2 pi 2 into 0 divided by 4 plus x of 3 e power minus j 2 pi 3 and 0 divided by 4. So by further solving this, we get x of 0 is equal to x of 0, and we multiply this 0 by 2 pi, again this whole term become e of 0 plus x of 1 e power, this is 0 so this also term becomes 0, plus x of 2, again the term becomes 0, plus x of 3, again e power 0. So x of 0 is equal to, what is x of 0? X of 0 is 1, so we get 1, and e power 0 is also 1, plus x of 1 is 2, and this is again 1, plus x of 2 is 1, and again this is 1, plus x of 3 is 0, so we are getting 0 and 1. So by solving this, we get 1 plus 2 plus 1 plus 0, which is equal to 4. If we expand x of 1 by taking k is equal to 1, we will get x of 0 e power minus j 2 pi 0, and where k is 1, here we have k, here we have n, divided by 4, plus x of 1 e power minus j 2 pi 1 1 divided by 4, plus x of 2 e power minus j 2 pi 0, not 0 but 2, and k is 1 divided by 4, plus x of 3 e power minus j 2 pi 3 into 1 divided by 4. And now if we simplify these terms, we will get x of 0 e power, this is again become 0, plus x of 1, and this become e power minus j pi by 2, plus x of 2 e power minus j pi, plus x of 3 e power minus j 3 by 2 pi. So how we'll get these value of exponent? If we make the graph, here we are taking the real axis and here imaginary axis, and we are draw a circle of radius 1, r is equal to 1. This is the graph of e power minus jx, where x is any angle. So we have get value at 0, which we have 1, because e power minus jx is equal to sine of x, not sine of, but e power minus jx is equal to cos of x minus j sine of x. And if we put value here 0, we get e of 0 is equal to 1, here we get 1. and if we put value in this formula minus j pi by 2, we will get pi by 2, it is equal to cos of pi by 2 minus j sine of pi by 2, and cos pi by 2 is 0, we have minus j sine pi by 2 is also 1, so we have minus j. And if we put value e power minus j pi, we have cos of pi minus j sine pi, so we have minus 1 minus j into 0, so we have minus 1. And if we put value minus j 3 pi by 2, we get cos 3 pi by 2 minus j sine 3 pi by 2. So we have cos 3 pi by 2 is equal to 0, and minus j into sine 3 pi by 2 we have minus 1, so we will get j. So we will use these values in our equation, so we will get x of 1 is equal to x of 0, we have 1 in our example, so x of 0 is 1, and e power 0 is also 1, plus x of 1 we have 2, and e power minus j pi by 2 we have minus j, and plus x of 2 we have 1, and e power minus j pi we have minus 1, plus we have here 1 j minus j and minus 1. So plus again we have x of 3 is 0, so this will multiply with this term and become 0, so here we have 0. And if we calculate this answer, we will get this is 1 minus 2j minus 1, and this will cancel with this one, and we will get minus 2j. Again, if we calculate x of 2, we will get x of 0 e power minus j 2 pi 0, and where k is equal to 2. Here we are talking about k is equal to 2 because this is our value of k and this is n, so divided by 4, plus x of 1 we have e power minus j 2 pi 1 with k is equal to 2 divided by 4, plus x of 2 e power minus j 2 pi, again we have 2 into 2 divided by 4, plus x of 3 e power minus j 2 pi 3 into 2 divided by 4. And if we simplify this term, we will get, we have x of 0 equal to 1, and here we will get 0, so e power 0 which is again 1, plus x of 1 is equal to 2, and if we cancel these terms we will get minus j pi e power minus j pi which is equal to minus 1, so we'll get minus 1, plus this is 1, and if we cancel this term we'll get minus j 2 pi which is nothing but e power 0, so we'll get 1 here, and plus x of 3 is 0, so x of 3 is 0, so the whole term will become 0. So this is 1 minus 2 plus 1, so this become 2 minus 2 which is again we get 0. So now we calculate x of 3 when k is equal to 3. So we have x of 0 e power minus j 2 pi 0 into 3 divided by 4 plus x of 1 e power minus j 2 pi 1 into 3. This is the value of n and this is the value of k, divided by 4 plus x of 2 e power minus j 2 pi. We have 2 into 3 divided by 4 plus x of 3 e power minus j 2 pi 3 into 3 and divided by 4. Now if we calculate this value, x of 0 we have 1, and if we cancel this term we will get minus j 3 pi by 2. Minus j 3 pi by 2, we have j. So first we have 0 here. If we multiply this 0, we have e power 0, which is nothing but 1, and plus x of 1 is 2. And now if we cancel this term 2 by 4, we will get 3 pi by minus j 3 pi by 2. Minus j 3 pi by 2, we have j, plus x of 2 is 1, and e power minus j 2 pi. If we cancel this term, we will get 3 pi, and 3 pi is nothing but minus pi, because here from here to here we have pi, 0 to pi, and again we have here 2 pi, and again half circulation we have 3 pi here, and we have same value, which is minus 1. So at x of 3, what we are getting, we have here 1 plus 2j and minus 1, and the fourth term will become 0 because x of 3 is 0. So we have 2j. Now I have drawn the amplitude response of our example that we have solved. At x of 0 we have 4, and x of 1 we have minus 2j, and the amplitude of minus 2j we have 2. If we put this value in formula, in amplitude formula, we have 0 square plus minus j square. So what we will have, we have 4 here, and we again get 2. So at x of 2 we have 0, and x of 3 again we have 2j, and the amplitude of 2j is 2. So this is our graph of the Fourier transform that we have obtained in our example. In this example, we have at 0 we have amplitude 4, and at 2 we have 0 amplitude. This means that we have, in this example, we have low frequency component. This is our f max frequency which we have 0 in this our example. Why we have low frequency component in this example? Because our sequence was x of n is equal to 1, 2, 1 and 0. So in this sequence we have less transition. If we have in our signal, if we have greater transition like a square wave, we have a lot of frequencies, because in rectangular signal we have infinite frequencies involved to make rectangular wave. So in this sequence we have 1, 2 and 1. There is not a lot of transition, so we have low frequency component. But if we take x of n is equal to 1, minus 2, 1, 0, we get the graph by putting this value in our previous equation that we have seen. We will get at 0 we have 0 value, and at 1 we have 2, and at 2 we have, and at 3 we have 2j. Here 4 2 2, and this is k, and this is x of k, amplitude graph when the sequence is this. So this is our f max frequency, and we have amplitude at 2 is equal to 4, and at low frequency we have 0 amplitude. This means that we have high frequency component in this graph. So why we have high frequency component in this graph? Because we have a lot of transition. From 1 we have transition to -2, and -2 to 1. So here we have larger transition. But if we have a sequence x of n is equal to 3 to -3 and then 5, here we have more larger transition, so we'll get more large frequencies in our graph. Now this is for our today's lecture. आज का हमारा लेक्चर कंप्लीट हुआ. मिलते हैं नेक्स्ट टाइम. अस्सलाम वालेकुम.